When we talk about AI these days, our minds immediately jump to things like ChatGPT, right? These large language models are, well, they're incredible, but they're not the whole story, not even close. So today, we're going to pull back the curtain on a totally different kind of AI. It's this hidden world, one that's built not on statistical guesswork, but on cold, hard, provable logic. A world where AI can think in a way we can actually trust and verify.
And this quote from Professor Ross D. King, it really hits on a massive problem in science right now, the reproducibility crisis. I mean, we're human. We make mistakes, our notes get sloppy, we misremember things. But what if a machine could handle the entire process of discovery? What if every single step was perfectly recorded, perfectly logical, every single time?
I know, it sounds like something straight out of a sci-fi movie, but it's actually happening. Professor King has built these robot scientists, and they've got great names: Adam, Eve, and Genesis. Their whole purpose is to do exactly that. They're part of this huge global push to create an AI smart enough to win a Nobel Prize by 2050.
Okay, now this is the part that'll blow your mind. These robots are not just fancy arms that move test tubes around. No, they automate the entire intellectual journey of science. They come up with a hypothesis on their own, then they design the perfect experiment to test it, and after they run it, they look at the results and figure out what it all means. They are literally deciding what to do next.
And look, this isn't just some far-off theoretical idea. It's already happened. The robot scientist Adam became the very first machine in history to autonomously discover brand new scientific knowledge. It was studying the genetics of baker's yeast and found things about its genes that no human scientist knew, which, of course, leads to the $1 million question: how on earth did it do that?
Well, the secret is probably not what you're thinking. The brain inside these robots isn't some bigger, badder version of a neural network. Nope, the breakthrough comes from a completely different school of thought in AI, one that's built on the ancient principles of formal mathematical logic.
And at the very heart of this is something called first-order logic, or FOL for short. The best way to think about it is it's not a programming language, it's more like the universal grammar for reason itself. It gives you a way to state facts and rules about the world with zero ambiguity, so that a computer can follow the chain of reasoning with perfect mathematical rigor.
So how do you actually use this stuff? Well, you use a language called Prolog, and it's beautifully simple. It's built on just 3 pillars. First, you just state the facts, simple truths about the world, like Socrates is male. Then you give it rules for how to figure new things out. For example, a thing, let's call it X, is mortal if that thing X is human. And finally, you ask queries. You ask a question, and the system uses pure logic to connect the dots between your facts and rules to find the answer. It's that clean.
So Prolog was the pioneer, the OG of logic programming. But of course, the idea didn't just stop there. It kicked off an evolution, sprouting a whole family of languages, each with its own unique philosophy and job to do. Let's take a quick look at some of the big ones. So first up, you've got Datalog. Think of it as Prolog's specialized cousin that's obsessed with speed. It's built for one main purpose: tearing through massive amounts of data. And here's its killer feature. It guarantees that any question you ask it will actually finish. That's a huge deal, because with giant databases, a poorly phrased question could just run forever, burning up resources. Datalog doesn't let that happen. Then you have Mercury. Okay, this is logic programming for the major leagues. This is what you use when you're building massive, industrial-scale systems that absolutely positively cannot fail. It's all about being fast, super reliable, and, this is key, provably correct. It's like having a hyper-strict engineer that forces you to build things right from the very beginning.
And then, on the other end of the spectrum, you have something like Oz. It's more of an academic, experimental language. It's kind of like a mad scientist's toolkit. It mashes up logic programming with a bunch of other styles, not so much for building commercial products, but for exploring the deep, fundamental questions about what computation even is.
So you can see, each of these languages makes a different deal. It's all about trade-offs. Prolog gives you all the flexibility in the world, which is amazing for brainstorming and prototyping. Datalog says, okay, I'll take a little of that flexibility, but in return I'll give you insane performance and a guarantee you'll get an answer. And Mercury demands you be very structured, but it pays you back with rock-solid, industrial-grade reliability.
Which really brings us to this perfect analogy for the 2 main branches of AI today. On one side, you have large language models. They're black boxes. They sound incredibly fluent. They're amazing with messy, ambiguous language, but you can't see how they think. Their reasoning is based on statistics, and they're famous for just making stuff up. On the other side, you have logic programming. This is a glass box. You can see every single step of its reasoning. It's verifiable, it's strict, and it's honest.
So you've got the rigorous, trustworthy glass box and the flexible, user-friendly black box. The obvious question then is, can we put them together? Can we get the best of both worlds?
And the answer seems to be yes. The most exciting path forward is this hybrid model. People are calling it vibe coding. The idea is you use the LLM for what it's great at, understanding humans. A person describes what they want in plain English. The LLM translates that vibe into a set of precise logical rules for a language like Prolog. Then the logic engine, our trusty glass box, takes that perfect code and executes it with flawless, verifiable precision.
So you might be thinking, if this stuff is so great, why isn't it everywhere? And that's the paradox. While you might not find a button to connect Prolog to Zapier, these languages absolutely dominate their specific, critical niches. Datalog is the undisputed king of finding security bugs in software. Prolog is still the brain behind cutting-edge symbolic AI. And Mercury is used to build mission-critical tools where being correct isn't just a feature, it's a requirement.
And that right there reveals their true place in the world of technology. Logic languages aren't really platforms you connect to. They're not apps. They're incredibly powerful, specialized engines that you build deep into the core of a larger system to solve a very specific, very hard kind of problem. And they solve those problems better than anything else out there.
Which leaves us with one final, big thought to chew on. We're entering a world where these black box AIs are creating an absolute tidal wave of information. Text, code, images, you name it. In a world flooded with AI-generated content, isn't the verifiable, logical certainty of a glass box system going to be more important than ever, just so we can figure out what's actually true?